That is the MPG for cars in terms of their model and their fuel efficiency. Yeah, and you can see here we have the highway miles that we were using to I guess this was the variable we were using to subset. So there are actually several ways that we can subset based on a certain condition, and we were looking at a number of ways that we can actually do that. Now when it comes to I'm trying to recall what we were really doing, but if I can remember, we were subsetting using the concept of matrices, where we are saying we are using the name, like for instance MPG, and then we need to specify what we want to get as the rows. Those are the number of observations, and as well as the columns. So now we were saying, for instance, I want to subset the data set MPG based on the variable that we were using yesterday, that is highway per miles. Okay, just a minute. I have to see. Okay, let's say highway per miles. But before I even do that, let me just observe the spread of the variables on highway per miles. Or I can see it from 18 to 30 something, 32. Yeah, but I can just say, to get the maximum, I can say max for the data set, and I get the highest value, so it's 44. So from 18 to 44, that is. So let's say, suppose we want to subset now the number of observation based on the highway per miles, miles per, is it I don't know, gallon or such. So maybe we say the one that is greater than a given number or less than. We can even say the one that is less than, let's say less than 22, less than 22. So the question is, what do you want to list for such observations whose highway miles is actually less than 25? Do you want to get the model of the car? Do you want to get the manufacturer? Do you want to get the year and all that? Or do you want to get the entire information? So I remember I was saying, if you want to get all those columns, then you won't specify for the columns. You can just run that and you have all of them listed. But again, I was saying you can actually have this and specify some columns or a column that you want to access for those particular sets of cars whose highway mile per gallon is less than 25. So I can say now here, suppose I only want to get the manufacturer. So because manufacturer is a name, and the name of the column, I'll quote and say manufacturer, and I need to write that as it is. That is where it is important. I first had to ask to use the header function to get the names of the columns. But when I run that, you see now it is giving me the manufacturer name, and this is for those cars whose highway miles per gallon is less than 25. Now when I was saying, now the other day I was also saying, if there are more than one columns that you want to actually access, you use the combine function and then you separate by a comma. So let's say I also need to get the year. I also need to get the year. You can also run that. Okay, something is not right. Something is not right. Okay, I didn't put a bracket here at the end. So yeah, and we have it. So that is one way of actually subsetting. Now the other way is to use what we call the subset function. There is actually a function that is used to subset, and this is the function. And I was telling you, you always can ask for help and see the documentation and the prototype of that particular function. So and I remember I was saying, I first normally ask myself, what is it that I need to subset? What is the name of the data set? It is MPG. The data set is MPG. Then I put a comma. Now, what is the rule of subsetting, of selecting those few observations that I want? So what am I selecting in simple terms? So you use the select argument to pass that argument as a condition that you want to access. So I want to access those whose highway miles per I don't know, it's gallon of water is less than 22, and I put a comma, Now again, the question is, do you want to access every other column based on these for those cars whose highway miles per is less than 22? You want to access all those columns, the manufacturer, the years, and all that information? If so, then you can just run and you have the columns listed. And remember, this is basing on this condition. So again, if you want to access a few columns, or rather a few attributes about those cars whose highway miles is less than 22, again you can use the combine function that we were using there. But before you use the combine function, you must instruct R that actually you select this. This is what I want. So I'll say select, and then I put that in a combined function if the column is more than one, and I run that. There's an error there. Someone to identify the error. Why am I having an error? Why am I having an error? Okay.
Prof.
Yes.
From syntax we used yesterday.
Yes.
Instead of the select, we say the subset.
Oh yeah, okay, yeah, you are right.
Yes.
The first one was supposed to be subset. Yeah.
Yes.
Subset. And then after subsetting, now we select.
Yes.
Yeah, very correct. You see now, you guys are very sharp. You are having this, and that is it. Thank you, Mr. Safe. The ups and downs to resolve the issues with the computers and such, by the time you settle, but that's it, and I don't know why, but actually it is just here for the documentation. X is the data, then the subset, then select, then drop. I said there is a name for those arguments that are passed in an order. What is that name? There is a name for that. So that is another approach that we can use now to subset, using the subset function. Now the most important one that we were talking about yesterday, I don't know if Mary has joined the meeting. Let me check, because I'm very far from the meeting. Am I far? I didn't join using my phone today, so I can't. Mary is here. Mary, can you hear me?
Yes, I can.
Your R Studio is okay now?
No.
It's still installing, or what's happening?
It's still installing.
Okay. So this is just a recap. You can just check, and then by the time we start what we are supposed to cover, I'll ask you again if you are ready to go. So I was saying that one important, and we'll always be using this, is the pipe operator. The pipe operator, basically what it does is that it takes the output of one statement and make it the input of the next statement. It is taking the output of one statement and make it available to be used as an input in the next statement. Now, in this case of subsetting, that is the general now the pipe operator, because we are not only using this pipe operator when it comes to subsetting, but in many scenarios it will involve subsetting, but it can be also applied in other ways. That is the pipe operator we are all talking about. Now, in this context of subsetting, it is normally wise to use it with what we call a filter and select function. The filter and the select function. You see, when we are subsetting here, we are actually subsetting and then selecting. So the same way, together with the pipe operator, we will be filtering. Filtering is now where we pass the condition, and then we will now do the selection, the normal selection now. Now, to do that, first the filter and the select function are found in the deployer package. So for us to be able to use those functions, we must first load our library deployer. We must first load the library deployer. So let's first do that. I load the library, and once I do, now I'm free to use those functions because they are residing in that particular library. Now this is how I subset my data, my table in this context. So what is that data you want to subset? It is the MPG data. So make it available. It is the MPG data. So it's like, by the fact that I just write MPG or normal circumstance and I run that, you see, it's the entire data set that is there with you can see they're telling me with 224 more rows. So it is the entire data set. It is there. So this statement, just calling the name MPG, brings the entire data set. So the MPG is the entire data set. So this is its output. So this statement, which is now the name of the data set, brings this output. Now we want this data set to use it. So this output, make it available so that it can be used by the other statement as an input. Now we use what we call the pipe operator. We use what we call the pipe operator to make this output, now the entire data set, available for the next statement. Now in the next statement is now from this output of the entire data set, which now we want to use it here as the input. We filter this data set using this one variable, that is the highway miles. That is the highway miles. So because we have made it available, the entire data set is now available. Now filter what? We are filtering the highway miles. Now what is that condition that we will use to filter? Let's say filter such that it is less than 22. It is less than 22. Now when you have filtered that output, now make it available for the next statement. So this was the first output, the entire data set. We have made it available for the second statement. So some values have been filtered here for the entire data set. Some values have been filtered, including all the the columns. Now it is being made available for the next step. If there is no any other step and we run that, we'll get the output. But now the fact that we have used a pipe operator, now that output to this point is made available for the next step. Now the next step is from that filtration, from that filter function, now select from the output of the filter function, which is now made available here. Now select, what are we selecting? So we can say select the manufacturer, select the manufacturer, select the manufacturer, and you can see by the time I write manufacturer, it is popping up. Why? Because it has already been made available. So I can also say select the model, and by the time I write D, it is already there because it has been made available, and maybe the year, and by the time I write year, it is already there because it has been made available. So when I run that, it is now giving me this desired output. So from this statement, from this one statement, you realize this is how it is happening. This is how it is happening. Maybe to just explain this pipe operator nicely, let me try to do this. Just a minute. Don't bother. I guess you guys understand what I'm doing. Now this is what is happening, and this is what I've been saying, but I like demonstrating. Now this first statement, MPG, it is the name of the data set. Now when we execute this, we are getting the entire data set. It is the output. Now this entire data set, the function of this filter function, the pipe operator, is to make this output of the first statement available for the next statement so that it can be used as the input. So the first one we're getting is this. Now this is now made available. It is passed to the second statement to be used as input. Now for the second, because we have it all, the data set, we are saying now filter where the highway miles is less than 22, is less than 22. And when we run that to that filter, we are having this output. You can see we have all this, but when you look at this, the highway miles is actually less than 22, but we have all the columns, that is the class, the highway, and all that, the driver, all that, the model, the manufacturer, and such. Now this output from the filter, from now the MPG to the filter, this output here is now made available for the next statement, that is now select. So from this, using the pipe operator, make it available to the last statement so that it can now be used as an input. And from this, only select the manufacturer, the model, and the year, and that is why now our final statement will give us this output. Will give us this output. We of course there are other rows, that is 22 rows. We can still observe that. So that is now how the pipe operator works. It takes the output of one statement and make it available as an input for the next statement, in simple terms. I don't know if you guys understand that. Is that clear? Yes, F is saying it's very clear. Amina and Mary. Is that clear? Or you're not with us? Okay, I can see Amina saying it's clear. Mary, are you with us?
Yes.
Now, what is happening to your R Studio?
I've installed.
And it's now open.
Yeah.
Good. So today we were supposed to discuss some simple aspects. I think we can still do so for the remaining 30 minutes. Programming is simple, like the beauty about us all here is that we at least have some knowledge of programming. At least, even myself, I just have some. You see, R is not as programming as such, as though it is a programming language. There is more of analytics. So we are looking at basic programming, where will be discussing some basic functions, or rather some basic issues to do with programming. Right from the beginning, it was all about programming the data sets and all that. But you can see our focus is on analytics, doing data analysis. So as far as we are discussing basic programming, I'll try as much as possible to make it in that statistical approach. So basically, what we are supposed to discuss is that is on what we call functions. But before we look at functions, we also need to look at statements. Like we have these statements that are called selective statements. We also have, it's iteration statement and such. So these are basic control flow that are used in R that we need to understand, because it's not always that as you are doing your analysis, you'll be using the inbuilt function. Actually, it will come a point whereby you need to figure out how to build a function and maybe do your analysis. I remember one time I was forced to do so, and more specifically when I was doing some data cleaning. You see, data cleaning is very, very crucial. Actually, you will spend a lot of time doing cleaning than analysis. So at such a point at times you'll be forced to create a function. Now I want us to look at to start with what we call the selective statement, and more specifically the if-else statement, or rather the if-else selective statement in this case. And we'll just look at the syntax, do one example as we move on. So the syntax of the if statement, because we all have that background in programming, is just the same like in any other programming language. It's just the same. So that I'll have if, then I have my square bracket like that. Of course, I'll have some condition there. That is now the syntax. And then after that, I'll open the bracket. That is now where I'll have my statement to be executed when now that condition is actually true, when the condition is named. And then I'll have my else, and now for the else here, we need to have that statement that will be printed when our condition is not true. So let's say I have a statement there. Don't bother about the spellings. I want you to understand. That is the most important. So that is basically the syntax. If, then we have some condition, and then a statement. So what is happening is that from this condition, if the condition is meant, like it holds, this first statement will be executed. And if the condition is false, the second statement will be executed. Basically, that is it. That is it. So maybe to do a quick example, a very simple example, now which example? Someone to give us an example. Okay, maybe say we want to compare numbers. So we have a number, let's say x. Let's say x is 2, and we have a number y, and let's say y is 5. Okay, 6. Y is 6. So we have x is 2. I need to run that so that it can save, and y is 6, and y is 6. So I want to compare these two numbers to see which one is greater than the other. So I'll assume and say, let x be greater than y. So if x is greater than y, and that statement is true, what am I supposed to print here? I can say print. Now R also use the print function, and it is under this R, so I can say print x is greater than y. Otherwise it should print x is less than y. So otherwise print x is less than y. We were supposed to quote that. Yes, we are. It should be quoted. Like that. And when I run that, you can see it's saying x is less than y. Because if x is greater than y, so when I look at x is actually not greater than y. So this condition is false. So the second statement will be executed. We said if the condition is true, the first statement will be executed. And if the condition is false, the second statement will be executed. So that is one function that at one point you might use in R. But now, you guys, we were once in the same advanced Excel class, and we were talking about the if-else function as well. Now we realize R also has a special function that is called the if-else. Apart from this one from general programming, R as a language has a very special function of if-else, which is very useful, and in most of the cases we'll be using that instead of this. And it returns one of two specified values based on a conditional statement. This is the syntax, just like the one, okay, this is kind of different from what you are doing, but it is if else. You can see it is in this R, if else. Now you can also ask for documentation if you are not sure, if you need to confirm the prototype of the function. Now you can see it is if else, then we have a test, that is the conditional statement, then the value to return when it is true and when it is false, and when the condition is false. So if now we can have that statement. So this time around we can say we were comparing 2 and 6. So I can say if 6 is greater than 2 is greater than 2, then comma. So the value when it is greater than, return true, but I can just write 1, otherwise return a 0. And I run that. and you can see it is returning a 1. It is returning a 1. It is just the same here, but now this is more simplified because we can actually make this to have the same. We can say we have a 1 here and we have a 0 here. We have a 0 here. So if now it will be y is greater than x, is greater than x, and it is giving the same output. Now look at this. You are doing a lot of work actually, but now here we have only one statement and it is giving us the very same desired output. So this function is actually mostly used, and the beauty about this if-else, the second if-else, is that it is very used to be, it is very easy to use it using a vector, So it can actually be used, or rather applied, when we have a vector. Let's just have an example. Suppose I have a vector, let's say I have a vector z, and this vector z consists of the elements. So because it has more than one element, of course I need to use the combine function. So it consists of the element 1, maybe 2, 3, let's just have random numbers, 4, 5, 6 and 7, even 9, 8 and 9. So that is my vector z. Now I want to check if the elements in z are greater than a certain number, then return this. Otherwise, return this other value. So you see, to check that using if, this first if we were talking about here, it will now be complicated because we need to bring an iteration and all that. But now it's simple to use this one compared to the first one, because for that I'll just say if else. So if what, the vector v, the vector z is greater than the number, let's say greater than 5. Now print what? Print let's say 1, that is true, otherwise print a 0, and I run that. So you see, it is comparing the values of vector one at a time and giving the desired output. So it is now very simple to use the if else than to use this second if else than the first with the block of statements. I don't know if you guys understand that. Is it clear? Now they both give us the same output. Now when to use entirely depends with you. Is it clear?
Yes.
Okay. Now having look at that, we can even look at the iteration, because you are saying we're bringing the aspect of iteration that we need to repeat doing something. So in such a case, we use now what we call the for statement, or rather the for function, sorry. Now for the for, it will repeat doing the same thing until a certain, as long as a certain condition holds, it will repeat doing the same. So the syntax again is just the same like for any other programming language. Like we are saying for, then we have that bracket, and actually it's an inbuilt function. So by the time you say for, you have the syntax. That is the syntax. Now you realize the for now in most of the cases it will work with a vector. It will work with a vector, because you see, for a variable in a vector, so we can say, let's have first let's have our variable. Let's say we have our variable x, and now x consists of the elements, let's say 11 to 15. 11 to 15, that is now our x. Now we want to test something about the x, or rather we want to do an operation on the x now using the for. So we can say, suppose for an element I that is in a vector. Now you see, this is a vector. So what is that vector? The vector can be 1 to 15. So suppose I is from 1 to 15, but that will be a lot of iteration. Let's say 1 to 5, 1 to 5. Now what do we want the function to do? I want the function to take x in I, and then this x in I should be equal to, let's say, x in I multiplied by 2. X in I multiplied by 2. It is not any complicated, because this is what is happening. Multiply by 2. Multiply by 2. So we run that. Okay, saying object I is not found. Just a minute. It is supposed to be okay. Saying object I not found. Let me just recopy that. I know what it could be the issue. Oh, where? Just a minute, guys. Are you having it from your end? Something is wrong from my end, but that doesn't mean it is not giving an output from your end. Who is having an output from his or her end? Okay. Yes, someone's hand is up. Can you just unmute and speak?
Okay, I have a question.
Yes.
We are using a variable I.
Yes.
Which you have not defined. Okay, does it work?
Which you have not declared. That is what you mean. Yeah. Okay. It is. I is an index.
Okay.
Of the vector. You see, when you look at the documentation, let me just show you. When you look at the documentation, okay, now you see they're saying for variable in sequence and all that. So I is a variable that represents the index. So it doesn't necessarily have to be declared. There is not an issue. But I'm asking, are you guys also not getting an output from your end?
Personally, I have not found.
Okay, let me just redo it from my end, and I'll tell you. X in I. So X in I, let's just put like this. Like by 2. Oh yeah, what was I doing? How can it give me an output and I've not called X? How? Can come back now? Yeah, sure. Oh, my microphone was still on. Okay. So actually you are correct. You see this this class, I think I was also not settled as such, but it is actually correct. Only that, okay, it was correct, but I had not called for the output. You see, I had not called for the output. Now this is this is what is happening. This is where now it is slightly different from other programmings you may find it. So, but it is generally the same, because we are having this one variable X. X. Now this X is the variable having the elements 11, 12, 13, 14 and 15. Those are the elements for the variable X. Now we are saying for I in this vector. Now I is an index representing the vector of 1 to 5, which means I is actually a vector of 5 elements, 1, 2, 3, 4, 5. Now we are saying for as long as I is within the vector 1 to 5, go to this X. Now X is a vector in this case because it is storing more than one element of the same data type. Go to this X, where the index is the index of this vector, which is now from 1 to 5. Take that value, multiply it by 2, and assign that value to that index. So it will repeat doing that, and then print that output. So literally this is what is happening. First we have created the vector X of the elements 11 to 15, that is 11, 12, 13, 14 and 15. Now for I in 1 to 5, so I is starting from 1 ending at 5. So for I is in 1 to 5, meaning it should not exceed 5, 1 to 5. So xi is the index for this particular vector, which is having element 11 to 15. So if I is at 1, because for I in 1 to 5, so assuming I is at 1, so xi will be the first element, because that is the index of the first element of this vector. So it will come to that vector, look for the first element, that is the element whose index is 1, because for I is now 1. Take that, multiply it by 2. So it will take 11, multiply by 2, that is 22. So again in that vector X, because the index in the index 1 now store 22. So it is like it is creating a new vector. Now after doing that, again we'll go back and check for I. Now we were done with 1, we are going to 2. So for I is now 2. Now xi, I now is 2. So it will go and check for the second element in the vector that is having elements 11 to 15. Now the second element is actually 13. Now take that 13, multiply by 2. The second element is 12 because 11, 12. Take that 12, multiply by 2, it is 24. Now assign it, reassign it to that second index. Now I now will be 3. So it will repeat doing the same until I now is 5. It will go to the vector, look at the fifth element, which is 15, multiply by 2, giving us 30. Store that again, reassign that to the fifth position of the vector x. Now we call x. X now will be that of the new elements 22, 24, 26, 28 and 30. I don't know if you guys understand that. Is it clear? Yes, sir.
I hope you can hear me, Prof.
Yes, I can hear you.
Kindly, let's redo this for loop.
Today or tomorrow?
Today.
Okay, the explanation part or the syntax?
I think the syntax isn't an issue, but actually I'm trying to understand what was it to do.
There is the bit I explained, and when I was like, is it clear? Only to realize I'm not in the meeting.
Okay, kindly.
Okay. So I was saying that this is what is happening here. We have first created a vector. This is the vector. The vector x is having the elements 11 to 15, meaning the vector x is actually of the elements 11, 12, 13, 14 and 15. That is the vector x. Now we are having the for loop here. Now what is happening here is that, and I will say this is now the case where the for loops looks slightly different, though it is still the same as other programming language, is the concept of matrix. I mean a vector. We are having a vector here. So we are saying I, for I in this vector, this I is like an address. You can see in this context. But the most important thing to understand is that for as long as I is in the vector of elements 1 to 5, then we will continue doing the operation that we are doing here. So I is from 1, 2, 3, 4, 5, because it is a vector of 1 to 5. So for I in 1 to 5, let's now assume I is at 1, the first case that is. Now x square bracket I, you can see that this is actually an address to access the first element of a vector. Now what is the name of the vector? The vector is x, which is this vector we have just defined up here. So for I in 1 to 5, now I is at 1, so xi is x1, x square bracket 1, which is the address of the first element of the vector. And we can also see that, the first element of the vector x is 11. So this one here means that address, which is now 11, this address represent 11 in that vector, is equals to the 11 multiplied by 2. So we are taking the 11 and we are accessing it using its address, and we are multiplying by 2. Now after multiplying by 2, we reassign that to that position of the vector. We are reassigning that to that position of the vector. That is in the first position because the address is x1. So this is what is happening generally. I is in the first case is 1. So xi is the address of the first element of the vector. It will come to the vector. Look, the first element is 11. Take 11 multiply by 2, giving us 22. Assign that to the xi, that is x1, the first position of the vector. Now assign 22. So instead of 11, we will have now 22. Now for I now it will repeat doing the same. It will not go back, and because it is start from 1 to 5. Now it is done with 1. It will go to 2. So I now is 2. And someone is asking, why is it increasing and there's no increment like in the other programming? It is increasing because the aspect of vector here, the vector here is forcing it to 1 to 5. So we are done with 1, we are going to 2. So I now is 2. So this address will be the address of the second element. Now take that second element in that vector, which is now in this case 12. Multiply by 2, we are getting 24. Assign that to the same vector in the second position. So now in that vector we'll have 24. So it will go for I3, I4 until it's I5, which is the last one. So x5 will be the last element, the fifth element in this vector, which is 15. Multiply now by 2, it is giving us 30. Assign that to the same vector in the fifth position. We are having that, 30. So when now we call that vector x, we have now actually done some operation on it and stored some new values. That is why now we are getting 22, 24, 25, 26 and 30. I don't know if that is clear. Is it clear?
It's well explained. Yes, thank you.
That is nice. That is nice. Now, that is, yes. Oh yeah. Okay. I see Mr. Sev is saying very clear. So, I was saying, what was I saying? There is now the for function. Now, one thing you realize is that, unlike other programming languages, where we will be using this for loop in many occasions, when it comes to R, we will rarely use the for loop. Why? Because the aspect of vectorization tries to simplify everything such that at one point you will not need the for loop. You will not need the for loop. But actually, you can just use a vector to do all that the for loops is doing. You only need a vector, because look at this. We are taking, basically whatever we are doing here, we are taking the elements of this vector and multiply them by 2. That is what we are doing. So why should we do that? Why should we waste our time to do that? And the concept of vectorization is very clear. So we can actually create our vector in simple terms and do the operation without the for loop. So you can say x is the vector of the elements 1 to 15. Now x is equals to that x now multiplied by 2. Multiply by 2. multiply by 2. So we have created our vector here, x. Now we are saying x is that x multiplied by 2. And now when we call x, you see it is storing the new values. The new values. So the whole aspect of vectorization now tries to simplify, and you see using the for loop at times it doesn't come, is not as essential as such because of the whole concept of vectorization. R understands vectors very well. So those are some of the statements that we are going to use at one point, the if, else, and the for. The if, else, and the for. But most importantly, there are other functions that we are also going to use that we have not discussed, and I want us to finish by discussing that maybe in the next like 10 minutes. So we want to discuss some functions, and we cannot finish them. We cannot finish them, the functions. Now basically, when it comes to R, there are several functions, right from what we call the R built-in functions that come along with the package. Now and then we were looking at what we call, we were looking at various functions, and we were saying this is coming from this package, this function is from that package, and all that. Like when we were using the main function, and we were like it is from base R and all that. So again, we can also create what we call a user-defined function. You can create your own function, but R is also trying to simplify the aspect of you creating a user-defined function, because as you're creating your function, inside that function you are creating, you can use the inbuilt function to simplify your work and to achieve your desired output. So basically, the syntax of a function in R will be the function name. We need to have the function name, and we have a bracket. Now after the bracket, we pass our arguments. We pass our arguments. So we can have our arguments there, as many as possible, separated by a comma. So we can say argument 1, and we have argument 2. Now what am I writing? Like that. And that is basically the syntax of of a function. Now someone is asking, what is an argument? Basically, an argument is a variable which is used in the body of the function. It is like a variable in this whole context of R. So when we specify the value of that particular argument, now we will be doing the computation. We'll be doing the computation. So I want us to create a very simple function, that we can all use. And one function that we will normally use and we mostly use is what we call, not actually a function that we'll be using, but one function maybe we can create that is very essential. It is yes, we have statisticians in the house. We said we cannot separate statistics and the aspect of machine learning and such. Now at times you have observations. Now these observations are not normal distributed. So at times you want to standardize your observation so that they are normal distributed. I don't know if you guys understand that. There is that context. So in most of the cases, you realize we'll be standardizing variable. Now, there is a formula to standardize a variable. Like we have observations, we have a sample of some values. and now we of particular elements that we want to discuss. Now those values are not normally distributed. There is a way we can actually standardize them. How do we do the standardization? What is the formula? Now in normal circumstances, we say suppose x is an observation. Let me write this as a comment. Suppose x is an observation. Suppose x is an observation. Those observations are represented by x. So we have this observation, x's in this case. We want to standardize them. So to standardize them, it is x the observation minus x bar. Now I don't know how to write bar, so I'll just say x bar like that, and then divided by the standard deviation, STD, the standard deviation. I guess that is the formula that we are using to standardize a variable. We are taking the observation x minus the sample mean over the standard deviation. Guys, is that correct?
Yes.
Yeah, so basically we want to create a function that is doing that. It's taking x. Now x is the number of observation. X is an observation. Suppose we have the age of 50 students. Now this age is not normally distributed, is not standardized. So we want to standardize. So we will be taking one, we'll compute the mean and the standard deviation. Now to standardize it, we'll be taking one observation minus the mean divided by the standard deviation. Another observation minus the mean divided by the standard deviation. That is what we want to do. So we need to do this using a function. Now normally, to create a function, you first need to give it a name. You need first to give it a name, and your name should be at least short. Should be short, and also try to describe what you are trying to do. Not that I want to standardize and I want to create a function to standardize, and I name my function rationalizing. You see, it doesn't make sense. So it should be descriptive in nature so that it describes what it's doing. Now we also need to specify your arguments, those variables that you'll be passing. You need to specify them. What is being representing your arguments in that function. So you will specify them in that particular curly bracket, and then in that curly braces, we have those brackets now where we build the body of the function. That is now where we implement our calculation. So let's try to create this function. Now we can call our function standard, or what is the name, because we have standard deviation. Let's just call it okay, standardize, something like that. So the name of the function is the standardize. Now standardize. Now in R, when you are creating a function, you always use this. You will always use the function. You'll use this function. It's confusing. In R, when you're creating a function, you use this function. Yeah, it's a tongue twister. Now the reason as to why I'm using function, because it is in that function that I'll pass my argument. So my argument is x. So x is representing the various observations that now I'll be standardizing. You see, you cannot say x is 20 because there are several observations. That is why I'm putting x. Now after passing the argument, now you open the curly braces. Now from here is where now we now create that body of the function, like what you are trying to do. Now you see that the first thing, we have x, and x is the observations, so x will be there. But now x bar is now the mean of the observations x. So we need to get x bar. We don't have x bar, so we need to compute x bar. So we can say x bar is the mean of x. So let's note it by m and say this is now the mean of the observations, the mean of the observations, the mean of the observations x. So we have computed the mean. Now we need also to compute the standard deviation. So the standard deviation is STD. Now the standard deviation is also given by, we actually have a function that is giving the standard deviation. So it is STD for the observation x. I mean SB for the observation x. For the observation x. So this is what I was telling you. We are creating a function, but we are actually using some inbuilt function to simplify. Get the mean of x, get the standard deviation. I'm using that function. Now we are now to implement our function, and our function is x minus the mean x bar divided by the standard deviation. So we can now say now what do we give the final result after we have standardized? What do we call it, that value? We can give it a name. We can call x, capital X standard STD, meaning it's capital X standardized, will be equal to, now how do we get capital X standardized? It is now the observation x, whatever we are passing in the function, then minus the mean, and the mean is stored by m. Then after doing that, now divide by the standard deviation STD, the standard deviation STD. I don't know if guys you understand this. So that will standardize the value, but it will not print the value. To print the value, we will have to call the final value. So x standardized, and it will print that value. So this function, the name of the function is the standardize. Now the argument is x bar. Now from x bar we have computed the mean of x, the standard deviation of x. Now x standardized will be x, the observation, minus m, which is the mean of x, divided by STD, which is the standard deviation of x. And we run that. We're saying object m not found. Did we use capital M and small m, or what is happening? These two seem to be different, but no, they are the same. Okay, let me just check. Guys, is it running from your end? Or I've been speaking alone? See, that is the worst. Guys, from your end, is it telling you that M is not found?
I said I have it.
Now why on my side is not? Okay, let me just no problem. My R is running mad. M not found. Okay, then I'll call my my min p, and it will tell me p is not found. Oh yeah. Oh, I guess now I know. Okay, let me just run this as a block. Oh yeah, that was the reason. You are to run the entire or run at end. Yeah. So guys, are we having our function x?
Yes.
Now we have our function. Now the question is, how do we use that function? So all we need to do is to have some values and pass them to this function standard. Because you see we have x, and x represent anything. So we can have some values and pass them. So suppose, very first, let's have our vector of the variable edge. Let's have our vector of the variable edge. So edge is storing our edge for this case. So let's say we have 25, 26, 27, okay, 21, 28, and finally we have 96. So that is the edge: 25, 26, 21, 28, and 96. I run that. That is the edge. So I want to standardize edge. I want to standardize edge, the variable edge, using. I want to standardize the variable edge using our standardize function. This function that we have created. So all I need to do is to call that function standardize. You just call that function standardize. The way you have write it there, if there is any spelling mistake, then just copy it as it is. So for me, I'll just copy it as it is, standardize, and then you pass that argument or those observations that you want to standardize. So from there, you put a bracket and you say, now my argument is x. So this x now is actually equal to edge. Those are the observations that I want to standardize. The reason as to why I'm using x is equal to the variable edge is because the x is the variable that was used in the function. So now in this function where there is x, put edge. I only need to have the function and do that. So when I run that, you realize it is giving me the values of the edge that are now standardized. The values of the edge that are now standardized. Those are the values of the edge that are now standardized. I don't know if you guys can see that.
Mine is telling me that the object is not found.
Which object?
The XSTD.
X
STD, yeah. The standard is that, yeah.
Are you running it from, okay, you are still running this part here on this function here, like, right?
No.
Okay, which code are you running? The standardized x is equals to edge.
Yeah.
Okay, what happened at first when you were executing this?
It is executed.
Now when you run this,
it's saying error in standardize x equals edge object XSTD not found.
Now what you do, just run this first, come back and run this. Okay?
Yeah. I still get the same error.
Is saying X STD is not found.
Yeah.
When running for the first or the last one.
The last one.
Now, are these two consistent? Just click that, and if they're the same, they'll be highlighted. Is in both cases X capital?
No, one was in small case.
I guess now you can see why. So is...
Yeah, it has worked.
Okay. Now, that is one scenario. But I like making things, I like making work easier. I like making work easier. Like, you see, instead of having all these arguments, there is a way we can actually create, rewrite our function in a more simplified way. Like, look at this. Why should we actually have the mean and all this? Okay, what I'm trying to say is there is a way we can write this function in a more simplified fashion. So I can copy this and modify this function so that I make it very simple to avoid such issues that we were getting. Like, for instance, here this function. The function is basically the mean of x minus, the x, which is the observation, minus the mean of x divided by the standard deviation of x. So I actually don't have to start declaring this, but I can have them at the end of, as they are. I can just have them as they are. I'm hearing myself. So this is what I'll do. I'll just say the x standardized is equals to x minus what? The mean of x divided by the standard deviation, the SD of x. And that is what we are doing basically. That is simple, rather than starting creating I don't know what and all that. That is simple. So we can actually use just that. We can write it in a more simplified way to avoid confusions and such that now if it doesn't make any we avoid such small mistakes. Now again, maybe to just tell you this, that at times we can generate data from R based on a particular distribution. Like, for instance, we can generate data using a normal distribution by specifying the number of observation, the mean, and the standard deviation. Suppose we specify the mean, the number of observation, and standard deviation for a normal distribution. Then we can specify, we can generate a sample. So, like, suppose I want to get a sample. Let's say I can say sample 1, and I want to generate this sample from a random distribution of normal distribution. In this case, it's random and normal distribution. So all I need is to know the number of observations that I want, their mean and the standard deviation. Then I'll use the random norm distribution. So from this distribution, it will generate random numbers based on a specified number of observation, mean and standard deviation. So you can see we have n. N represents the number of observation. So I can say maybe I want for 15 observation, and let their mean be 25 and the standard deviation be let's say 5, and I run that. So I have actually generated a random sample that is normal distributed. So when I call sample 1, you see I'll have that particular data set. So that data set is normal distributed with a mean of 15 and a standard deviation of 5, and it has n as 15. It has 15 observation. So again, even though it is normal, you can still standardize that. You can use the standardized function that we have created here and see if you can standardize that. Now using this new function that we have created. So you can just copy that, come down here, paste, and now say x is equals to the sample 1 we are using, the sample 1, the data that we have generated. And when we run that, you see now those values have been standardized. I don't know if you guys are getting that. Guys, is it clear? Hello? Or I've been speaking alone? Yeah, I can see Mr. Saif is saying it's clear. Now, our time is actually up. We are okay. Actually, I didn't see this. Amina is saying my output is the same as the command standardize x is equals to h. Yes, I mean, I'm not getting this. This is supposed to be 7 minutes ago. What was the issue?
I've rectified it.
Okay, that's nice.
The second command.
Okay. So, because our time is up, I want to give you an assignment, one that you can try. There are two formulas to, okay, we have the variance given distribution, and I'll even simplify this and make it simple for you. There is what we call the sample variance, which in most of the cases it is denoted by sigma. I know you have heard about sigma. And for the sample it is represented by s squared. Now there are two. We have one that is called the biased and the other one is unbiased. Because that sigma is being estimated. I mean, the sample variance is an estimation of the population variance, that is. So it can be biased or unbiased. When you are looking at theory of estimation, we say one characteristic of a good estimator is that it has to be unbiased. And it's said to be unbiased when its expectation is the same as the mean of the population. So that aside, but the thing is, we have two formulas for computing the sample variance. We have the one that is for the unbiased and the other one that is for biased. So I want you to go and try to implement that. And the formula is, I'll actually give you the formulas if I'm not wrong. For the unbiased, S squared is equals to 1 over n minus 1, 1 over n minus 1, 1 over n minus 1, summation of x minus x bar squared, summation of x minus x bar squared. That is the one for biased, for unbiased. Now the one for biased is just like the same, but now instead of 1 over n minus 1, we have 1 over n. Then the summation of x minus x bar squared. That is now the biased. Now I want you to go and try to implement that using R, like creating your own function. Then after you have created your own function, you can generate a random sample. You can use the normal distribution that we were using, the function, to generate a normal distribution and then get its variance using your function. Or you can actually have a vector, like a vector, and try to get the variance, and then you will come and pick from there. And just to give you a hint, if you can check actually if your answer is correct or not, because in R we already have a function that will give us the variance, the function var. So this one will give us the variance. Like for the case we have age, if I say var age and I run that, it must give me the variance. And this variance by default is the unbiased. So you can actually check if your function is giving you same as the one for the unbiased, and from there now we will say you are correct. So I'll share the formula if you still not sure, but it is basically just a small thing. Try to do it and then we'll see. And because of that, we have come to the end of the introductory part, and you see we have 10 days to finish our first month.